So in this video, I'm going to be sketching a reciprocal function. Remember that reciprocal functions are, the most simple one is f of x equals 1 on x. But we can use our general form here where we're multiplying it by a, that's going to be like our dilation factor. We're shifting it to the left or right by h, and we're shifting it up and down by k. Okay, so here's an example. Let's sketch the function f of x equals 3 on x minus 2 plus 5. First of all, we need our Cartesian plane. This point and this point are going to be really, really important because that's going to be our x-intercept of the asymptote. And this is going to be our y, I should call it, not intercept, coordinate. This is going to be the y-coordinate of the asymptote. So I'm just going to put those two in a spot. Minus 2, it's going to be the opposite of that. So it's going to be positive 2, 1, 2. And positive 5, it's going to be exactly what you see there. 1, 2, 3, 4, 5. Okay, so that point, 2, 5, are our horizontal and our vertical asymptotes. That's where the reciprocal function gets close to but never touches. Okay, so that was step 1. Step 1, draw asymptotes. Now, step 2, I'm going to say step 2 is to consider the shape. Consider shape. Now, there's only going to be two basic shapes for our reciprocal function. Either it's going to be here and here, so in these quadrants, or it's going to be here and here in these quadrants. Now, it's going to be in this quadrant and this quadrant if A is positive. A positive. It's going to be in the first and third quadrants. Boom, boom. And if A is negative, obviously it's going to be in the second and fourth quadrants. So we can see A is positive. So the rough general shape is going to be there, there. Now our last real point here is to draw in a point. Now I'm going to do step 3. We call it a significant point. It really can be any point you want to, well, really can be any point, but the y-intercept and the x-intercept make the most sense. So I'm going to find the y-intercept. I'm going to let x equal 0. A lot of us are not writing this stuff when we do these things, but it's really, really important that you do that. So find the y-intercept, let x equal 0. That means that f of x equals 3 over 0 minus 2 plus 5. That's 3 on 2 plus 5. That ends up being 6.5. Okay, so it's going to have a y-intercept of 6.5. So I found a y-intercept of 6.5, then I looked back at it, and 6.5 is up here, but I already knew that the general shape is in here. So I must have stuffed something up. What did I stuff up? 3 on 0 minus 2. Okay, so that's 3 on negative 2 plus 5. It's not 6.5, it's 3.5. You can just type that into your calculator. So 3.5, that makes a lot more sense. 1, 2, 3.5, good. It passes through there. Now I just draw a rough shape of what it's going to look like. And I try to match this side so that they look the same because they're mirror images around this axis. They're mirrored image. Now, for the sake of completeness, I can find the x-intercept by letting y equal 0. 0 equals 3 on x minus 2 plus 5. Negative 5 equals 3 on x minus 2. This takes a little bit of mucking around. Negative 5 times x minus 2 equals 3. Negative 5x plus 10 equals 3. You can see we're sort of moving stuff around. 10 moves over here. 3 minus 10 equals negative 5x. Negative 5x equals negative 7. X equals negative 7 on negative 5. X equals 7 on 5. That's 1.4. 1.4. Label these points. 3.5. Okay, and there's our sketch. Asymptotes, significant point, and if you want to, throw another significant point in there as well. We've got all of our sketching in business. All right, that's it.